All right, my friends, finally the conclusion of Chapter 10, Section 2 notes. I'm actually going to skip number 18 here in the interest of time, but I do wish to point something out to you. And that thing that I'm pointing out is the fact that you must check anytime that you are searching for an argument. So the fact that this x in this problem is in the argument position, when you get your final answers, you have to check. So it very, very similar to number 17. It ends up being a quadratic equation to solve. You get two answers. But what I did want to mention was it's possible to solve one of these and just have one answer, and it checked, it worked. It's possible that we could have two answers, but in that case, the one problem that we checked right here did not work, so we had to eliminate it. But for number 18, you end up with two answers, and both of those answers check. But the only way you can find out if they check is to check them. So I'm going to skip down here to the property of inequality. So the property of inequality, pretty much, well, exactly the same as the property of equality, except we're talking about greater thans and less thans. But the point is, if you look at number 19, there is a log base 10 on both sides. So I get to cross them off. But the argument, 3x minus 4, it's not just an x this time. So it's a little more involved, and I'll get to that in a minute. But for now, let's just go ahead and solve it like we did on the previous video. And you're left with those two arguments. I'm going to subtract x from both sides. Oops, pause with 6 left over there. I'm going to add 4 to both sides. I'm going to divide by 2. So I get that answer. But what we discovered in that last video is that the argument cannot be negative. So how do I guarantee that this guy right here is not negative or 0? Well, I need the 3x minus 4 to be bigger than 0. So I'm going to write that out mathematically and then just solve it. Add 4 to both sides. Divide both sides by 3. So you got 4/3 or 1.3. 1.3 repeating if you want to go decimal. Well, here's what makes this problem rather lengthy and tedious. There are two arguments. There was another argument that said x plus 6. But x plus 6 better be bigger than 0 or it's impossible to do. So I'll solve that one as well. Subtract 6 to both sides. I got 3 answers. Well, how do you combine all 3 answers into one final answer? This answer is supposed to be bigger than 4/3, smaller than 5, and bigger than -6. Where's that at? Here's the best way to find out where it's at. Use a number line. So I don't know about you guys, my tiny little brain cannot handle figuring out where the final answer to all 4 of these are unless I actually take the time to do the number line. 4/3, 1.3, roughly right there, but it's definitely between -6 and 5. So way back, we did this. Open circles if you do not have the equal sign. So if I'm going to graph this guy, open circle, greater than, shade to the right. See if I can go with some different colors here. This guy, x is less than 5. Open circle, less than, shade to the left. This guy, x is greater than -6. Open circle, greater than, shade to the right. So where do they overlap? And we're looking for not just 2, 3 this time, all 3. Well, they don't all overlap here because that's the only one shown on the red line. They don't all overlap there. Granted, 2 of them do, but not all of them. And then clear up here at the top, well, yeah, you got the black line and you got the blue line, but you don't have them all. So here, this location right here is where all 3 overlap. I didn't have anything but open circles in the problem. And there's where all 3 overlap. So how do you write an answer that's shaded in between 2 numbers? Well, there's the answer. If I write 4/3 there and if I write 5 there, it's between them. So hopefully you remember, we always put less thans for that answer. So there's how we represent a shade that's in between 2 numbers and the final answer to that problem. The answers are between 4/3 and 5. Not smaller than 4/3, not bigger than 5, but in between. So that's lengthy, I will admit that. There is a lot involved, but the actual solving of the 3 problems, pretty darn easy. All right, finally, the last problem in Chapter 10, Section 2. So maybe it would be a good idea to do this. Up to you. Since the hard part to remember is that the arguments can't be negative or can't be 0, maybe you should write that down first. There's another argument, x minus 4. It has to be bigger than 0. And then the problem itself. Well, here's the property of inequality. You are allowed to cross off those common bases and just solve what's left. So I get a 2x plus 1 greater than or equal to x minus 4. And then just solve all three. So I am going to subtract 1. Sorry, not an equal sign, greater than. Subtract 1. Divide by 2. X has to be bigger than negative half. Pretty easy to solve this one. I got to add 4 to both sides. That argument has to be bigger than 4. So I'm going to solve this one very similar to the way I just solved the last one. Subtract x from both sides. Really? 3x? No, I don't think 2x minus 1x. Let's try that again. That's why it's a good idea to put the work underneath, guys. So that's 1x plus 1 greater than or equal to negative 4. Subtract 1 from both sides. I get a negative 5. So if you can take those three answers and somehow combine them into one final answer like we did there without doing the number line graph, you are smarter than me. I'm going to take the time to do it. Right order. I got a negative 5. I got a negative half. I got a positive 4. Doesn't really matter what order you do them in. X is greater than negative 1/2. Open circle. Shade to the right. Second argument, x is greater than 4. Open circle, greater than, shade to the right. Third problem. Hey, that one says x is greater than or equal to. So this time I do have to go with a closed circle, and that could be important. But that guy's also greater than, shade to the right. So where do all three overlap? Nothing down here, only one here. I've got the top line and the bottom line, but not all three. The only spot where all three overlap right there. So I'm going to leave off the circle for just a second, but I am going to shade. So there's going off to the right forever. So the open circle or the closed circle is clear down here with the negative 5. There's no shading there, so I'm not going to concern myself with him. This open circle is not where the shading is. I'm not going to concern myself with him either. But this open circle went with the 4. So that's what the 4 gets. There's my final answer. So this time it is not shaded between. This time I do not have to write it like this previous answer up here. That's the one for shade between. So for this one, all I have to do to come up with a solution set is describe where the answer is. So if I asked you, where's the shade? Do you have to mention more than one number, or are you just going to say one number? Hey, where's the shade? It's from 4 on up. So I don't have to write any other number but the 4. But how do you mathematically say that an answer is bigger than 4? Well, you write a greater than symbol. So x is greater than 4. And you have finally reached the conclusion of the chapter 10 videos. So if you have watched all 4, congratulations. You have my eternal gratitude. Thanks for watching.